Here's another problem for equilibrium in 2 dimensions. So in this case, you have a straight, I think, bar here, which is supported, pin supported at A, and roller supported at B. And there is an applied load of applied moment of 800 Newton meter and an applied load of 15 Newton at point B, perpendicular siya at point B. So, before anything else, let's find the unknowns. And these unknowns are the reactions. So, since it is spin supported, we have AX is unknown, AY is unknown. And since B is a roller, you have your BY is also unknown. Right? So, that's it. So, you have your AY here, and since going there, your AX should be going to the right. Question, ngano padulong man dito ang AX? Of course, you examine the entire system, and this point here, the load application is going dinha, so therefore it has a X component of dinha and a Y component of dinha. So therefore, if this loading is contributing a force towards the right, then it should be balanced by this reaction AX so that it will stay in its place and it will be in equilibrium. So muna siya din ha. Okay, so let's start. Our solution will be, let's go back to the first and simplest form, ang triangle. So we have a triangle here. You have your 8 meters and here, so you have your, if that is 8, this is 12, and this is 5. So our Y is unknown and our hypotenuse is unknown. So by the power of similar triangles, you will get 12 is to 5 as to 8 is to Y, and you will get to Y is equal to 3.333 meters. Right? And we will find this H. This H is, are you familiar with the formula of having H? So that is C squared is equals to A squared plus B squared minus 2AB cosine theta. Right? So C is equals to the square root of A squared plus B squared minus 2AB cosine 90, because this is 90 degrees. Right? And your A is your 12 and your 5 is, your A is 8 and your B is 3.333. So you will get B, C here. We will just neglect this 1, 5, and 12 because our focus will be here, and this is the triangle that we are trying to solve. So C is equals to 8 squared plus 3.333 squared minus 2 times 8 times cosine 90 square root of answer. You have C is equals to 8.667 meter, and that is your. Now let's proceed to our what is asked in our problem. So A. So we have, since it is equilibrium, summation of all forces along X must be equal to 0. So forces along X, you have your positive to the right. So you have your 500 and the component along X is 500 soka. Opposite here, opposite, this is opposite. So 3.333 over your C is 8.667. That is the force here. Component of 500 Newton along X. This one. Minus AX is equals to 0. Therefore, your AX is equals to 500 times 3.333 divided by 8.667. And you will get 192.28 Newton. That is your AX. Then summation of forces along Y must also be 0, and our convention going up positive. Okay, so going up we have AY plus BY, then minus 500 soka adjacent, this one adjacent, so you have 8 over 8.667 is equals to 0. And we have two unknowns and only one equation, so we will proceed to our next equation, which is the summation of all moments at point A must equal to be to 0. Our convention clockwise positive. Okay, since we have moments at A, summation of moments at A, so these components here are wala na, diba? Wala nag-create of moment because pass through siya sa point A. But we have our applied moment here. So summation of moments at point A is equals to, since clockwise is positive, $500. We'll use 500 because we already know that the moment arm here is our C, right? So since it is clockwise, 8.667 plus our BY, which is negative BY, I mean negative since it is, sorry, negative since it is counterclockwise, and plus 800 Newton meter is equals to 0. So we will get our BY here, and that is equal to 500 times 8.667 plus 800. So you have divided by 8 And you will get By at 641.688 Newton. So we will go back here. AY plus BY minus 500 times 8 over 8667 is equals to 0. Therefore, our AY plus 641.688 is equals to 500 times 8 divided by 8.667, and that is 461.52. AY is equals to minus 641.688, and our answer is negative 180.167 Newton. And since it is negative, therefore, and our sign convention is going up, therefore our AY is 180.167 Newton going down. So that's it. I'll repeat, okay? First, we will get the summation of forces along X, 500, and the component of 500 Newton along X is this one. You just use the opposite over hypotenuse, sine theta. So instead of using sine theta, you have your opposite of hypotenuse minus AX, because your AX is going to the left and your component here going to the right. So that's, you get your 192.25 Newton. Then summation of forces along Y must be 0. AY plus BY, our assumption is that going up positive, so we have positive AY, BY minus 500 cosine, since the component of Y of 500, that is along X, so SOHCA and just 8 over 8 hypotenuse ni siya sa C, this one C. So since two unknowns, you cannot solve it, you have to use another equation. Summation of moments at A must be 0. Assumption positive ang clockwise, I mean, so you will get this 500, and your moment arm is the value of your C, so 500 times 8.667. Emotion patuyo kun diri sa A since it is perpendicular. And BY, you have your BY here, and the distance from A is 8 meters, so you have minus, since this one tends to rotate counterclockwise, this one, and 800 since it is also clockwise. It is also clockwise here. So let's solve for BY. You will get BY positive siya, so therefore our assumption nga going taas ang BY, pasaka siya, sakto. But since we will also find the AY pa, so AY, our assumption is going up positive, but you get an AY of negative, therefore our assumption is wrong. Supposedly our AY should be downward, so we will get get back here and correct our assumption that it is not going up, AY is going down. That's it, our problems for equilibrium in 2 dimensions. And you can solve other problems in your textbook and practice solving so that it will be much easier for you para sa tuang problem sets. Okay, and I will post it this week. Thank you for watching and I hope you learned something.